Yeah, so anyways, for those of you who don't know me, my name is Evan Schmidt. I'm the outreach coordinator here at TDI. A little intro to TDI for those of you who don't know. We are a research collaboration between University of Oregon and Oregon State University, focusing on advancing the state of the art in timber construction, generally speaking. And so a lot of our focus is on mass timber, of course, these days. So our research tends to be relatively applied, and we also provide various other sort of academic services, including education, training, and testing services for industry. Today, for our meetup, we're going to be talking about forest fires, forest restoration, and of course, mass timber. It's got to come back to the engineered wood products. And this nexus is really the result, just to kind of give a big picture here, why we're talking about this, the result of a century of fire production combined with climate change, turning into an era of what has been called mega fires. So I'm sure everyone here is relatively familiar with that. Anyone living in the West is all too familiar with some of these fires. And it's becoming widely evident that long-term management practices and climate change are impacting forest dynamics, impacting forest resilience, and that our forests require some amount of active stewardship in order to avoid these catastrophic corrections, if you want to call it a big mega fire a correction, from otherwise occurring. So this stewardship needs to reflect a relationship between human beings and our natural landscapes as one of balance of give and take. So many experts are agreeing that we need to restore our forests by mechanically reducing fuel. So I think that's generally what we're speaking about when we talk about forest restoration. But our experts, John and Marcus, may have some nuance to that. And so, restoring, we're thinking about mechanically reducing fuel, sometimes referred to as thinning. But the barrier to this has lied in both the costs, so the cost, sort of general economic viability of restoration work that tends to produce fewer and smaller trees, but also red tape, sort of at the government level. And then I guess finally some sense of trust in forestry practices. So it's a pretty dynamic field with lots of different voices. And the point will be to kind of explore those different voices and build some sense of understanding and maybe consensus. And of course, science is a powerful tool to help build trust and consensus. So we're hoping this keeps important surrounding these sort of general activities going. And yeah, hopefully we can collectively move towards some kind of solution that has a potential to be a win-win. In this case, win-win could be pretty big in that there's an opportunity to restore forests in an economically viable way by using the products or the trees from restoration in that value-added engineered wood products, excuse me. Sort of in tandem with that, these products would store the carbon that would otherwise off-gas during a forest fire, and the restoration work also results in more resilient forests. So that's sort of big take on what we're talking about today. I'm not a forester, so I'll leave Marcus and John and Tom and Lech to add nuance to this conversation.
Yeah, I don't know, Evan, that was pretty much my talk. So we could just go straight on to Marcus.
And mine too. Evan kind of knocked it out of the park. So there you go, folks.
All right. Well, yeah, that's good. At least we've got the stage set.
Perfect.
Yeah, I think
I'll show him some goodies.
We're going to take questions now.
Yeah, well, hey, now we get something exciting. We're going to do a poll. This is our first poll. So bear with me for a second while I pull this up. This is the first time I've used it. All right. I'm going to share my screen. And then I'm going to share this presentation. So anybody here, you'll use your phone, you'll go to www.menti.com there at the top of the screen. And then you should be using that code, that eight-digit numeric code to log into this questionnaire. And then you should be able to answer this question there. So in this case, you'll be ranking 4 options. This is a question from John Bailey. What areas of the forestry and forest restoration management most need addressing today and going forward? So we'll give this a minute because it takes a little bit to log in and read. And John, if you want to add anything to this while people are voting.
Yeah, just trying to get a sense from the group as for all of us as to where we might focus the kind of standard presentation pieces we have, plus just anticipating where questions might go. But you guys are not helping at all.
All right, we got five votes so far.
I feel like I should get a sticker. I voted.
Oh, okay.
I'm on the edge of my seat here. It keeps changing. It's like,
Yeah.
Remember those horse races from your kids, the ones you shot the water guns at?
Yep.
totally. They always do those at like baseball games.
Yeah.
So we are going to talk about all of these things. So it's good that it's jiggling in and out a little bit and all. So yeah, that's good.
Cool. Maybe we'll give it 30 more seconds.
Okay. It's kind of like bidding at an auction.
All right. Last chance, people. Okay. Well, John, you ready to move on, or do you want to say anything?
Yeah. If you want to close down, I'll share my screen.
Yeah. Well, we got one more. We got a couple more questions, and then we're gonna.
Oh.
Yeah. And then we'll start with John. We'll start with Marcus, and then we'll.
Oh, Marcus gets to go first.
I'll be brief. Don't worry.
Okay, so this was John's second question. Though not perfect, which of the following more strongly reflects your feelings about the potential for restoration work going forward? And so the two main answers include forest management that restores the resilience of forests to future climates while providing wood for expanding demand is a win-win. And the other is linking these two issues together is a mistake, since both are future unknowns and the success failure of one should not impact the other.
Yeah, I guess a loaded question for this group.
We'll give it 30 more seconds. It looks like we kind of know the trend though at this point.
So there's not going to be like the beat the buzzer shot.
All right, well, the crowd seems optimistic that there is a opportunity for both here. Now I got one more question, so just bear with me here while I get our last question going. And this one is from Marcus. So you'll have to enter a new code. We were chintzy, the free version of Menti, you only get to ask 2 questions. So that's why we had to do a new presentation. So you'll have to log out and log back in using this code, unless it's the same and I didn't notice.
Well, how can we work around this? Well, traditionally, this might be accomplished by sketching just the cross section of the cut you wanted to make.
All right, we'll give this another 30 seconds and then we'll get started with our panelists. All right, okay. Well, we can review this again later if we need. Marcus or John, we can come back to these results from my understanding. But with that, I'm going to hand off the presentation. We're going to start with Marcus Kauffman, who's with Oregon Department of Forestry. Marcus, I'll let you introduce yourself. And then after Marcus, we'll hear from John Bailey, who's with the College of Forestry here at Oregon State University. Then we'll hear from Tom Baun, who's with Vaagen Timbers. And finally, we'll hear from Lech Muszynski at Oregon State University College of Forestry, Department of Wood Science and Engineering. So, Marcus, take it away.
All right, well, thanks for having me. And I'm excited to be here to talk about this topic. It's pretty intriguing and interesting developments that are happening. A little bit about me, I'm the biomass resource specialist for Department of Forestry, which essentially my job is market development for wood products and bioenergy. So I've been doing that for about 8 or 9 years. And then I'm also public information officer and I support our wildfire suppression team. So I'm out on the front lines on our wildfires during the season. So I kind of bring that lens to it. And my perspective on these things is essentially kind of looking for market-based solutions to forest management. So that's kind of where I come from and what my background and history is. I'm just going to give a few kind of opening remarks about this general topic of like why we're talking about it and set some context. So I'm going to share my screen here if I can. Share screen, go to that, share. And just to start with a couple of orienting maps. So when we're talking about the connection between fire, forest management, and mass timber, the fire problem is not exclusive to the east side of the Cascades, but it's generally more predominant on the dry side. So you can see my cursor, we're really talking about stuff on the east side of the Cascades, these dry east side forests in both Oregon and Washington. So if we go to the Washington there to Oregon, we're talking about a larger swath, Eastern Oregon, Southern Oregon. And we know from last season's fires that this didn't just occur in Eastern Oregon. It's more of a wider spread problem, but this problem of fire suppression is more predominant on the east side. So just wanted to show this kind of quick illustration of really the problem that we're trying to solve with these forest management. This is a series of drawings that show on the one side what goes through a dry ponderosa pine forest when we have natural fire occurring. They're kind of come down at time 0, 20 years, 40 years, 60 years where fire occurs, and then 80 years with this open kind of park-like stand. And then below this illustration that says, well, if we have 100 years or 80 years of fire suppression, this is this dense forest that we get, right? So that's essentially the problem that we're talking about with turning that material, trying to turn it into CLT in some way, shape, or form. So thinking about that, where are the facilities right now that deal with CLT, and what's that wood source? Oops, sorry about that. So right now, this is a map of existing CLT facilities and existing sawmills. And we want to point out that, most of the wood supply for CLT comes and mass plywood comes from Doug Fir. And you can see the mills that are located along the west side of the Cascades predominantly. And there's very few sawmills in this area. And this is kind of the dry area that we're talking about, particularly in Oregon and Northern California. So the predominant material that we're talking about turning into is Doug Fir that comes from the west side. So what's exciting here is the potential to have a market draw for this material that comes from restoration on federal forests. And so let's dive into a little bit about what that problem looks like in particular, and I'll give you kind of a couple examples. So this is a widespread problem across our region. The Forest Service estimates that there's 10.4 million acres on national forests in Oregon and Washington in need of some sort of thinning or prescribed fire. And that was in 2017, 10.5 million acres. And a million of those acres are within a quarter mile of people, right? So this is both a forest problem and it's a problem that affects our homes and communities. And I think we all seen the impacts from last season's fires. So it's a big widespread problem. And then if we delve down a little bit more onto the Colville National Forest that we'll be talking about in more detail, essentially that forest is 1.5 million acres. And according to one of the planners on that forest, about 600,000, 800,000 acres on that forest needs some sort of treatment, thinning or prescribed fire. And they're able to accomplish about 12,000. And of that, about 5,000 to 6,000 is commercial treatment. So they have a huge scale of a problem, and they're only able to address this very small amount on a particular year. And what does this do when we have that market that we're talking about? Essentially, those treatments cost around $550 to $600 per acre if there's no market for the material. And what Vaagen is able to do, and what others are going to go into in more detail, when they have that reduces that cost. So the take home from all of this really is that, we have a treatment that lowers that cost, gets more acres treated, and improves fire resilience. So that's kind of the market-based solution that I'm excited about, and that others are going to kind of delve into more detail. And I think the opportunity here is to think, we have this one example on the Colville, but we have a widespread problem across the region and actually across the West, where this same kind of manufacturing technology and approach could be applied. So I'll leave it there. I just want to kind of set this up that there's a market-based solution here, which is showing some real promise.
Great, thanks, Marcus. John,
Certainly.
that is up to you.
Theoretically, you're seeing my screen now, Oregon's forest?
Yeah.
Yeah, good. So yeah, just pick up right from there. There's this potential solution, and so now what I want to do is give a little bit of detail, at least from the Oregon perspective, on where that comes from and how silviculture and fire ecology, fire management play into that. So, it's a massive resource that we have in Oregon. Washington actually is very similar, and so don't feel left out there. Those of you that are in Washington, Douglas Fir, Marcus already mentioned, is top, and so it's the gold color and the green color there on the west side of Oregon, and that's where it's actually on the west side. It's actually 80% of our land base. And all comes from, but we don't forget the potential of that ponderosa pine resource as well, but much less productive in terms of the sites that it grows on and its inherent genetics. But a bunch of it is timberland. And then here's that version of that ownership map as well that shows for Oregon, again, similar for Washington, that a whole bunch of it is on federal lands. And that 22%, I want to draw your attention to the 22% on industry land because it's going to reflect some of the potential of what we can do here. The dominantly, but not exclusively, but dominantly, those acres are on the productive ground on the west side, and some of the more productive ground on the east side as well. So there's a little bit of productivity difference, but there's also a big management difference that's going to drive some of these numbers that I'm going to show you, because despite only being 22% of the land base, it's producing 65% of the volume, harvest volume that's coming out. And despite the fact that 60% is federal land, it's producing only about 14% of the volume coming out. Again, a little bit of difference in productivity, but primarily a difference in management approaches and land management objectives and everything. And for scaling, that the amount that industry is moving is 2.6 billion board feet. So, it's approaching a million truckloads, or, something like that. A better part of a million truckloads, or hundreds per day. No, thousands per day that would convert to. So, it is a huge resource, a big volume that's moving. It's going dominantly to structural timber now, but I think we're looking at other sources than, competing with structural lumber to get to some of the other parts of the land base, in particularly small diameter woods to meet some expanded demand due to cross-laminated timber. So, the big question is, wow, how do they hit well above their weight class, so to speak, to generate that much of the harvest? And it has to do with these management practices and the interest in the poll about what are the impacts of these different styles of management practices. And so industry is dominantly using clear cut harvesting and that kind of thing, which I got to be clear is to many people ugly, but it not at all destructive or unsustainable. It's very different from deforestation. And that as a change in land use, where a forested acreage becomes agriculture, or becomes some permanently not forested, becomes a housing development, a Walmart, or something like that. That we have to distinguish these clear cutting practices from actual land loss kinds of things. There's no way to get around the fact that it's a large scale disturbance. But often, not even that noticeable within decades and within our lifetime as it regrows. And, we have all of the rules and regulations and just the ethics of the profession to grow the forest, reestablish the forest and grow the forest. Harvesting is just part of it. And a good 90% of the volume that industry is moving is coming from the clear-cut harvest practices. But there is a chunk of volume that does come from these kinds of thinning approaches, and that's going to have some relevance for cross-laminated timber as well. But here is the message about what the potential is for a lot of the other acreage or some fine-tuning on industry lands as well. If you look at the proportion of their land and standing growing stock, 3/4 or more of it is harvested. And then the gray bar net change is kind of the accumulation of trees and fiber on the hillsides. And that's a good thing. That's like growing your checking account, your savings account, that we're actually currently accumulating biomass, even on industry lands, despite those harvesting practices. Of course, it's fiber, it's wood, it's habitat, it's those things. It's also fuel, and it's part of what's burning. And then 11% mortality, some people might frown on that. Some are very excited about that because from an ecological perspective, the life of some organisms and all starts once the tree is dead and standing there. The value of snags and down logs and all of those kinds of things and the roles that they play. So 11%, may not be too bad there. But in contrast, and state lands aren't very different from that at all. But federal lands, only about 8% of what's growing out there is being utilized. 92% is accumulating, either in a living form or a sizable part now that is accumulating as a dead material, which is definitely a fuel concern. And so what that balances out overall. It looks at that most of the annual growth in Oregon is just accumulating as fuel on the landscape. So and I'm going to put my silviculturist hat on and talk about the kinds of things that we do as land managers. And one of the more important ones is the concept of density management. And so here's just some images from experimental plots, right side by side with very heavy control of the spacing of the trees and the growth rate. So these are the same age trees. These are immediately adjacent to each other. They've been maintained and measured over time. And so we could get into all the charts and figures, but I'm just going to show the pictures. But you can grow on a particular acre of ground. You can grow a lot of small trees. And then as you thin them a little bit, you're going to allow a little bit of understory to develop. Down here, but generally you're focusing production on a fewer number of trees that are going to be in larger diameter. And as you reduce the density further and it grows over time, you can enhance the amount of growing space that becomes available for things on the surface. And you can drive larger individual tree growth, but you're starting to sacrifice total fiber production on that acre. Because you're leaving growing space for things down here. You're not fully utilizing the growth potential of the site. And finally, at this lowest density, which are we think of as more similar to like Marcus's figure for areas that burned repeatedly, once or twice per decade, and kept densities low and kept a lot of material down on the forest floor. This would be analogous to those kinds of things. A lower density stand, very large individual trees, but giving up overall per acre productivity because you're maintaining a more open stand. So this is a research plot I did in Ponderosa Pine. I've done some of this work as well in Douglas Fir and how like old growth Douglas Fir develops at these kinds of low densities. In this picture, if we could do a picture of old growth Douglas Fir when Lewis and Clark, came through this part of the world. Here's one of those dense areas of fire exclusion for 100 years. I went in and took out 9 out of 10 trees. And in the ensuing 12 years, got regeneration and a lot of grass and beautiful wildflowers and all kind of ecosystem responses to that thinning and burning treatment. And the wildfire risk is much lower thanks to the level of fuels and the openness of these canopies now. So this is kind of our restoration of the composition and structure to make it more resistant and resilient to fire in the future. So here's what we're stuck with is in Western Oregon, Western Washington, from the Northwest Forest Plan and in just other socio-political phenomenon is we've come out of a couple decades of the dominance of the preservation model and the idea that we can take our current conditions and if we leave it alone, it just grows and grows and grows and grows and grows and grows and grows. And a little bit is lost to wildfire and other mortality agents out there. And that this is how the Oregon and Washington forests work. In reality, it doesn't. Certain areas will grow for a while before they burn. Some burn right away. When it burns, that wood and that fiber, splits and Some starts to decay and some will start to burn if it survives the fire, or it regenerates and then it splits some more. It's a complex world out there, particularly in these parts of the West, most of the parts of the West that have a history of fire, low severity, mixed severity. A little bit of high severity fires is very natural as well. But this is how it actually works. The preservation model is still a failure. And so, we have to adopt, more of a conservation model. And this idea that, we can reserve some areas for whatever reason, at least for a while, limited in time and space, we can reserve some area, and they're going to grow and grow and grow for a while, but sooner or later, something's going to catch up with them. But really, we need to manage most of the landscape, balancing growth and harvesting. That's how we're going to actually maximize the amount of forest land and the amount of carbon on the landscape. And a certain amount of that's going to drain out of the system as prescribed fire or wildland fire use or the wildfires themselves, and we'll start going into that decay pool. But the idea is going to be, if we want to maximize the amount of forest land we have and the amount of timber that we're producing and the amount of carbon that is sequestered, it's really going to be right down that middle of balancing growth and harvest. And we have the silvicultural tools to do that. So with that, I'll pass it off.
Thanks, John. All right, Tom.
Very good. Let's see if you guys see that okay?
Yep.
Okay. Well, thank you very much. Thanks for the opportunity to speak to this group. My name is Tom Baun with Vaagen Timbers. I am a not born and bred, but pretty close, born and raised right in this area out of Colville. I grew up here, raised our kids here, and continue to be here. So this is exciting for us because I grew up in the woods and my kids grew up in the woods. And so to be able to watch these things come aboard, it's very exciting to know that there's a future in this for my grandkids and their grandkids and everything else, which is why a lot of us are all here. This is a very passionate thing for us. So I'm excited to be part of Vaagen Timbers because that's a big passion of ours. Obviously, there's a lot of history there with Vaagen Brothers Lumber and generations prior to those guys. So anyway, Russ and I grew up together. We actually graduated together, and I've been drinking the Kool-Aid a long time that they've been talking about, and so it's neat to see it kind of come to fruition. When you're a kid, that's one thing, but then as we grow up, I've got a ton of family in the logging industry and in the timber industry, and so to see this change and this thing morph into something that's really awesome is exciting. Doing the right thing for the right reasons is always important in everything we do. So with that, I'll kind of go through this and go through. I'll be honest. I will say that you guys have pretty much covered all this stuff. The era of mega fires is upon us. You guys know that. We know where we're at. Anybody that lives over here, when we were kids, very few of us saw many wildfires. White Mountain was one that was close and local, and we got to see smoke. And oh, geez, now anymore, all summer it's not uncommon to go up onto a peak and not be able to see to the other peak. So that's what's upon us, and it's a scary thought. This has been kind of an iconic picture of ours. This particular stand of timber was due to have a management practice upon it about 6 months prior to this, and this is where we ended up. And you can see the obvious overgrowth, dense, overpopulated problem that we run into a lot of this, right? And this is what we're trying to avoid and prevent in so many levels, and this is what we're trying to get to, I think, on the bigger scheme of things. We have a project that we've talked about a little bit. It's called the A to Z project in Kaufman National Forest. It's around a 55 to 60, 50-some thousand acre project, and a project like that with collaboration, coordination through National Forest Service and different entities, and I think those are really exciting to see. And there's going to be more and more of those as we go through this thing. The idea of taking that last landscape picture onto this landscape picture with using the small wood, there's a lot of strength and pros on this type of wood. You don't see any big massive things in there. You know, most of this stuff is a 12-inch or smaller or about there. And our catchphrase is, you know, we use the downfall or the byproduct of a sustainable forest practice. And that's exciting to say. And if you think about that, dig into that a little bit, it really means a lot. And when we can take this thing that in the old days, a lot of that stuff, these 4.5-inch tops would have been ran over or piled or burned on site, right? Or chipped or whatever the case is. Now we can take those products and those small diameter logs and turn them into some really cool stuff. This slide represents kind of that circular economy and the forest to home type concept. Obviously, the mill up here, you know, right across from us, I can't quite see it from here, but I look around the corner, we can. So we're close to that. Goes in, you know, produces the lumber, and from there it comes into this type of facility where we make these great CLT, GLT, glulam products, and they can be turned into so many different things in so many different ways. So from that, and they don't have to be big, they don't have to be massive. This is an example of a really awesome staircase that we did that, you know, it's small bits and pieces. So it's kind of a soup to nuts type thing where we can cover the board with that, from a real small item like this to this modular concept and this idea of having this small, quick build. Each one of these buildings, this is a blockhouse life project down in Spokane. This is a finished project. So, you know, I mean, obviously internal, that's all, the whole thing's CLTs. Those went up in 2 to 3 days a piece ish, right in there. So it's pretty exciting to do that with the modular concepts, which is becoming very popular very quickly. Then this is kind of a pseudo modular. This is a really exciting project called Matt's Place. It'll be in Spokane. It's kind of a in-kind thing that we're doing. It is a Matt's Place. It's kind of a conceptual. This is it, but we're going to be built this year, and it's an ALS home. And it's Matt's Place is Matt's Foundation is a charitable deal. A veteran that has ALS, and this is going to be his home where he has this living space for the ALS concept, and then for the living space for the rest of the family, so they can integrate really well. And then to a bigger piece, the last biggest piece is, I think we're fairly familiar with this building. We've seen, you guys might have seen some pictures of it, and we've seen some of it going up. So we were thankful and very excited to be a part of this project. Obviously, this is OSU campus building that went up. And so, you know, again, that soup to nuts, those small pieces to the big pieces, there's a lot of ways that we can integrate this through and take this together and grow as a group. There are times when mass timber isn't the right answer, but there's also times that we know that we can integrate it in where it needs to be integrated with. And I think as the mass timber industry grows, we'll be able to see that sustainability carry through and it become more and more popular, and hopefully more and more sustainable practices and treatments are put into place to allow more of this amazing industry to grow. So that kind of covers it for me there, everybody.
Thanks, Tom. Yeah, very, very fascinating to see restoration products being put to actual use. Real life examples here. We've got one more speaker to hear from. That's Lech Muszynski at OSU Department of Wood Science and Engineering.
Hi, everyone. Thanks, Ivan, again for the invitation. So I'm going to speak just out of one slide for a change. And my talk is going to be about research. So we've heard a lot about fascinating stuff that is already in motion. And research is about things that are missing in the picture, in a sense. And even though you can recognize all of the pieces and bits and pieces in this diagram here as existing, there are still little things that we think we can tweak and help and provide change that is more impactful. So as you have heard from John and Marcus and from Tom, the selective harvesting or the preventive landscape treatments, these are very different from commercial harvesting. And from our point of view, when we are looking at the material being generated as the raw source for composite products, for structural products, this creates sort of a problem, right? Because now when you are doing selective treatments, you are more likely than not to target smaller, weaker trees, and the distribution of the quality in fiber harvested that way will be very different from what you get from a clear cut from commercial harvest. Now, the research question is here, how much of this fiber can be used in structural products of certain quality? And it is true that certain part of the selectively harvested fiber still meets the requirements, the contemporary requirements for what needs to be used as raw material for mass timber panels. But the research that we are engaged with is exploring how we can expand this margin, how we can tap on fiber this from, as we currently understand it, from commercial point of view, of lower or hardly acceptable quality. How can we turn it into a quality structural products? So this is one piece of here. So as you see in this diagram, some of these logs may already find their commercial home easily, right? And the research and what the good part of what Vaagen is doing is finding home for the smaller pieces in here. So the next question is, mass timber panel industry, as we see it right now, it's a boutique industry. It's very small in scale. The global production is about 2 million cubic meters. If you wish to translate it to cubic feet, it's going to be like 300 something million, right, cubic foot globally. In North America, it's a small slice of this, right? So the current potential of the industry to process this lumber is relatively small. And this also comes with another caveat. The mass timber panels currently are going to this white swan, white unicorn, high profile projects. That limits very much the application of where this fiber can go, and raises the price, because mass timber panels are not commodity products. You cannot just buy them in Walmart or Home Depot, right? You have to buy a project, and they're being part of a project. If project is expensive, you pay premium for the panels. So the next research question is, can we find applications that will help utilization of this material in volumes? And this would be much less glamorous, smart, modular, repetitive units that can be used in a variety of applications. This could be used for solution of the affordable housing problems in the very same region where this material is being harvested and produced. This could be used for rebuilding communities that are ravaged by fires or other disasters. We are all in the seismic zone, right? We know that certain things do happen and will happen sooner or later, right? Rebuilding communities, not just single homes, is part of the equation here. Now, could we think of a modular solution that will be inexpensive to fabricate, to make, quick to assemble, and quick to deploy in communities where there's a need for quick rebuilding? Now, we also do research in the area of trying to capture this as a systemic solution to these problems. Essentially, portions, elements of this entire development that has been described today is landing on taxpayers' purse, right? It's on taxpayer purse to pay for the treatments, right? It's on taxpayer purse to provide for this rebuilding funds. You don't see it on, it's not a very easy connection, but this is coming from public money in large extent, right? And then the other problems that may be solved that way, like this shortage of affordable housing, right? Or solving the homelessness problem, or solving any post-disaster crisis. This all lands one way or another on a public budget. So if each of these looked separately, may look as a very expensive proposition, right? Or a very expensive necessity, if you wish. But when you look at it as a system, where one thing helps to solve another and helps to solve another and helps to solve another, right? With the manufacturing being this, the engine for the local rural economies, a job provider as well. So, you know, all of this is entangled. So the research is coming also in trying to frame the elements of this as a pieces of a systemic puzzle. One thing that I would like to add is that CLT is not the only mass timber product that may be considered. There are fascinating products being developed in Europe. This double bonded cross-laminated timber does not use adhesive at all. It's being produced on highly automated lines and has the capacity to serve in this kind of low-rise structures, modular structures that we depict in here, right? And other is nail bonded cross-laminated timber, or massive Holzmauer, as it is being called, or massive wood wall, as it is being marketed in Europe. These are complementary products that can be used in here. And then again, mass timber, as has been said before, mass timber panel industries cannot be the only solution. It has to be a part element of a more holistic solution to this entire thing. And this is where our research goes. I'll stop at this, and if there is interest for more details, I would respond in the question session.
Great, thank you, Lech. All right, well, so we're entering the discussion question and answer phase. So yeah, you're welcome to put any questions in the chat directly, and I can kind of moderate them for you. And you're also welcome to just ask them directly through the meeting here. I know I have about 1,000 questions, so I don't want to hog all of our Q&A time. So maybe I'll see if anybody has a question first, and if not, then I'll go for it. So looks like we have one in the chat already. I think this is for you. The question is, in line with modular replicable housing design being more cost efficient, I've heard that it can also reduce the waste in materials associated with one-off projects. Intuitively, it makes sense, but I'm wondering if you can speak to the sustainability side in this regards.
Thank you. This is a very good question. I don't think there is much waste in this one-off projects, right? They're more expensive because any new daring technical solution, the rise up, the funny angles, right? The beauty of the architecture, it requires more research. These are, it's pushing an envelope. And I don't think it's a waste, but it costs more. This is where the reputation of mass timber industry being more expensive than alternative construction technologies comes from. Now, the modular buildings, low scale, low rise modular buildings that are thought as a versatile solution for many different applications. So a modular system that could be used as housing units, as hospital, as medical facilities, as hotels, as community centers for the rebuilding communities, right? This is something that you design once, you do research on once, and then can be used in somewhat varying configurations for a multitude of uses. And this is where the price may be competitive with alternative technologies, where you can start building the volume for this industry. this is also something that may attract new manufacturers to the industry that would target different clientele, so to speak, than the current industry. So it's not going to be threatening in any sense. It's going to just widen the application for this technology. Does this respond to the question? Oh, the sustainability of this. I think it depends how you define sustainability in here. And again, there is nothing unsustainable with the large scale white unicorn projects, right? These are more sustainable than similar projects being executed in concrete, steel, glass, aluminum, right? Here, the sustainability is going to come, the angle on sustainability is going to come with the scale. Because currently, the entire mass timber industry in North America is capable of making, only a small dent on the material that needs to find its commercial home. And if you can provide solutions that can encourage scale in this industry, that would definitely help in the sustainability of this entire concept in the system.
Thanks, Lech. Any pressing questions?
I have a question for Tom, if that's okay.
Sure.
Yeah, I'm curious. I know that you guys only make a 4-foot wide CLT panel. Is that because you're targeting more the low-rise kind of residential market? And is there a relationship between that and the fiber that you choose to use?
Great question, and thank you for bringing that up. Actually, there was some calculated plans on that when Russ started with the process. There's a couple main things. I mean, we had kind of an idea where we were going to target, but that was still out a ways. But the main idea with the type of press we have, the RF press, was the fact that the 4-foot panel would encompass a lot of things, but we were able to make beams and panels out of the same press. And so we have a 4-foot wide offering up to 60 feet long. And that covered a lot of bases for a lot of things. So the idea, I mean, this is somewhat the idea was we would crawl before we walked and walk before we ran. And it's funny because most of the cases, our customers have been really excited that they ended up using the 4-foot panels. And because of their ease of use, their transportation eases. And then also, if you're looking at a really, really large concept project, obviously picks and time is a concern. And for the ones that we've done so far, it hasn't really been a concern because of how you can move that through. So I would say because you're looking, depending on the scales, we've had great success with that, and it wasn't calculated out more than we could do multiple things at once. And again, our goal is to have a larger press, hopefully within a couple of years and or less, to be able to do to that larger press size. Does that answer kind of what you're looking for there?
Yeah, I guess also to Lech's point about trying to find valuable uses for the really small diameter fiber that might have lower strength values than PRG 320. I was just curious to see whether you thought about, well, we couldn't use this in big spans or anything like that, but we could use it in small housing modules or that kind of thing.
Sure. No, and I think at this point, I mean, there's definitely, we actually have an E-rated panel which went into the OSU campus building. So with the utilization of the small wood, basically one of the big steps was to use that MSR machine stress rated wood into that and trying to pull from that group of fiber, just take out that really high end stuff that was able to do that. And obviously a heart center versus a jacket board, there's strength tendencies that each one of those have, but we've been able to feel pretty successful about that. And actually a GLT product, which we've been doing a lot of that lately, a project that went back to New York, Brooklyn, New York. They used GLT instead of CLT, and for a single span, that GLT has a stronger span length than the CLT, but it only has a single span versus the double span strength there. So at this point, that small diameter has fit the need of what we've had, and without any real robust spans that have been offered. I think that we've so far felt pretty comfortable with that.
Yeah, and I just wanted to weigh in here too. It seems like, I mean, if you go back to that picture that I think it was you, Tom, that shared it with some of the smaller diameter trees in the back of a truck.
Yeah.
From my impression, some of the smaller diameter trees that are coming out of restoration projects actually are pretty tight grained, high quality wood. And it seems like, that maybe it's the thinnings from private kind of commercial rotations that tend to be, some of this sort of less dense, lower quality wood, and that you might get a kind of a different spectrum of quality depending on the restoration work that you're doing or the thinning work that you're doing. And I imagine it's regional too. So I'd be curious if anybody here had a thought on sort of the spectrum of quality that we're getting from this kind of work.
Great point, Evan. And that's something that I didn't hit on too much earlier, but you will see, you get a 60-year-old tree that's this big versus a 6-year-old tree that's this big. There's definitely some strength characteristics there. So our main Doug Fir Larch DFL is kind of what we do. We've obviously worked with you guys on the ponderosa pine, and then there's an SPF offering that's out there as well. But that Doug Fir Larch, especially with the tight grain, you find some pretty good strength densities that you might not get in some of the larger stuff, at least on the smaller boards anyway.
And that's where the potential raw material is that just isn't being tapped, needs to be tapped, I would argue.
Yeah.
I would add to this that the material generated from this or mass timber panels produced from this material, against the popular belief, they do not need to meet any of the predefined PRG 320 grades. You can define whatever grade, custom grade of panel that if you wish, right? And this can be, do not have to have this high performance that the predefined panels have, but they may be completely enough for lower race applications.
Excellent point.
On kind of a tertiary sense of density, I was wondering if you guys could discuss a little bit, like how do you determine the target density for a stand? Like at what point in time or what density do you say is ideal for a landscape? Because I'm assuming in restoration work, you say, okay, our target is to bring this to some, basal density or whatever, or stand density. So I was just wondering like what metrics are used for that, and then kind of touching on that or going beyond that, like John, you shared a slide that I think it was your last slide, kind of looked like it was saying, we need to move towards this model that's more like growth, harvest, but then you also have these sort of transitioning arrows to maybe sort of introduced fire management.
Mm-hmm.
I was wondering, like, is the long-term vision for restoring these public lands lean more towards sort of a mechanical reduction of fuel and then pushing towards like a sort of like an introduced fire management, or is it a combination of harvest and fire? Or
yeah, very much the combination. I'll take the first one on. There isn't a silver bullet density, that you plant at or that you establish going into stem exclusion phase. It depends on how fast you want the individual trees to grow, what your land management objective is for how much fiber you want to produce. You can influence the straightness of the trees. You can influence knot size depending on how thick you plant them, and when you start doing pre-commercial thinning, if you're willing to do that, or when you start commercial thinning. But that thinking about density, managing that density, just like species composition. It's an objectives kind of thing, and we've got millions, billions of dollars of research behind how to do it. And it's driven by landowner objectives for what you want to grow. But the basic answer in silviculture is yes, we can grow that. different densities and all those kinds of things. Then the second point on that figure for moving forward, if we had a different land management approach, particularly on federal lands that involved that more of a conservation ethic of regular entry, proactive management, harvesting, that might be more either you could view it as long rotation with lots of thinnings, or I think it's better to view it as actual multi-age management, uneven age management, just regular entry and tending of the stands in there. But the mechanical component of harvesting meets this wood need and treats the coarse fuels, a dominant part of the pool of coarse fuels that are growing each and every year. But a big issue are the fine surface fuels. That's what typically propagates wildfire, propagates your prescribed burning program as well. So certainly the most efficient way to deal with fine surface fuels is through prescribed burning, or maybe a wildfire burns through it for you. But as long as the weather conditions aren't too extreme, then the wildfire is doing the work for you, and or can be part of your suppression program and protecting the wildland urban interface, and all of those kinds of things. So you can get into a complex part, but the harvesting deals with the coarse fuels, and prescribed burning deals with fine fuels.
Thanks. Yeah, and just kind of following on this, I don't want to take up too much of
Evan, if I might.
Yeah. Marcus, go ahead.
Yeah, just another thought to throw in there on the social side, since we're talking about public lands. A lot of how agreement happens on these national forests is generally through collaborations, and that's been a central part of the A to Z project in Washington, but also in Oregon. This concept of greater social license, getting to what they call zones of agreement, where local stakeholders work out what they're comfortable with, where they use the applied science to come to an understanding and then make a recommendation to the national forest. That's been a critical piece. We're thinking about this from a market-based perspective, and the market needs supply consistency and supply certainty. And if you're dealing in small landscapes that have a lot of contention and there's a lot of litigation, then that certainty is at risk. So that collaborative component is really central to the whole equation of working and being successful on public lands.
Thanks, Marcus. Yeah, that actually kind of clarified what I was about to ask, so that was perfect. It looks like we have a question from Camille.
Yeah, thanks. I'll turn my video on. This might be a little repetitive to a question that was asked a little while ago, but I have talked to other CLT manufacturers, and my information might be a little outdated, but they have said that they need at least 2x6 dimensional lumber to make panels, mostly 2x8, sometimes 2x10s. And I know that Vaagen is doing it, and we need more companies like them, but in other areas, is it actually realistic to assume that we can use restoration timber? In our area, generally restoration timber is anything less than like 12 inches DBH straight out of the forest. So after you process it at the mill, it comes out smaller in terms of dimensional lumber. So are there other products that could use 2x4s and something smaller? Maybe you said that and I missed it, but just curious to hear anyone's thoughts on that.
I can start with that if that's okay with everybody. Camille, great question. And actually, 2x6 is kind of our mainstay for what we do, but we also can use 2x4 as well. There is an 8 and a 10, and some of that depends on what you're certified for finger joint and everything like that. And in our finger joint piece, we can do 12-inch and down. But 2x6 for us is kind of our mainstay. And I know that the mill will take typically 12-inch DBH is kind of the big stuff, and then it goes down and go all the way down to a 4.5-inch top. And so, of course, when they run all that through, they maximize that output from that. But typically, the stuff that we're seeing is, and we really push for a real low wane type finished product. The crossomellas and everything else, you can have different applications for that. But for us anyway, definitely a lot of 2x6 mainstay, 2x4 as well in there, and then you know, you can go up from size, and especially with the GLT and the glulam stuff, we can do up to a 2x12 product. But that's a low end. That not a low end. That's the wrong verbiage. It's not as common for us to use those.
I will add to this that technologies exist currently and being used in Europe and being looked at some companies here in North America as well, where you can actually edge bond layers before you put them into a CLT. And in this case, the width of individual lamination is not as much of an issue as it is where you're just laying up the entire panel from the loose laminations. It could be adapted. I think there may be some efficiency going like halfway instead of or quarterway instead of edge bonding entire layer, which may become then somewhat difficult to from the internal plant logistic point of view, to edge bond wider laminations that may be like a foot or two in width. And this should be much easier to handle, much easier to manipulate, and may provide a way of utilization for this lumber that are 2x4 or 2x3 even. Then we come to a problem of 2x2, which are problematic because they are difficult to handle on a manufacturing line that can fall, you know, either way on your line. You don't want that. It creates a issue.
How about hue sawing like hexagonal wood and piecing it together like honeycomb?
These are I've seen trials with triangular rather than hexagonal, and it is harder than you think to put a consistent lamination or layup out of this.
I'm glad Russ isn't on here, John, because he'd hear that and we'd be off on a tangent. So that's good stuff. Thank you.
And also to Camille's point that, you know, the mass plywood panels can take material down to about 5 inches, and you know you can make, because they're pulling off veneer versus pulling 2x6s, right? So that's primarily out of Doug fir, but it also gives the ability to use that smaller dimensional fiber and is more efficient than, you know, making rectangular lumber out of a round log.
Thank you, Marcus. This is a great point because somehow we left out one of our local manufacturers, Forest Brothers, who produce mass plywood panels exactly out of sheets of veneer. Whether this technology may be successfully or let's put it that way, commercially made out of ponderosa pine, right? That's another issue, but we need to talk to Forest Brothers. But definitely it is possible to process much smaller logs.
We got a thank you, Lech. We've got a question that I missed here in the chat, and it's a good one I want to put to the group. Any thought on how to get the sustainable harvesting of federal lands to be recognized similar to the FSC, SFI, et cetera, for LEED or Living Building Challenge acceptance, et cetera? So I guess kind of like, how is this recognized, or how is this sort of like restoration, how are these restoration products recognized and promoted?
Marcus.
Yeah, I'll take a stab at that. Well, first thing, that the certification systems are inherently commercial schemes that are designed to give the consumer a sense of assurance. It's kind of the checkbox idea that, you know, you're buying a product which comes from a sustainable forest. And our federal lands are managed for a whole wide diversity of values, and they have a very rigorous system of planning projects through the National Environmental Protection Act. That level of rigor probably and easily exceeds FSC, SFI, and those other certification systems. Plus it's public, right? So as a stakeholder, you can engage in that process, you can object, you can litigate. So that it's a process which has a lot of opportunity for public comment to it, which doesn't exist in the certification systems. So, I think that the advantage of the certification systems is it just gives you this kind of sense, this little check off, and you can have some confidence in that. Whereas on the public side, it is very rigorous, but you have to look into the details of it. And from my perspective, you look at the depth of environmental planning that goes into these projects, and it's quite sustainable and rigorous, but it's hard to kind of pierce through that veil. So that's kind of the problem, is that it's more obscure and harder to just look at it and go, oh, it's got the check mark by it. But that doesn't mean that it's not sustainable. Hope that answers the question.
Yeah, and I don't fully understand the history of why you can't get the RIN credits or something like that on public lands and all. But that's because it's a socio-political process that led to federal lands being excluded from that.
So in part, it sounds like in part though, just a matter of education and kind of general outreach, just people understanding what's actually happening on the ground.
And policy change.
Yeah. So speaking of which, I'm curious if you guys can describe, like, what does restoration forestry actually look like on the ground? I mean, if people think forestry, I think there's a lot of different conceptions and visualizations of what forestry is. And my guess is there's probably still some kind of dark box component of this. Like, what does restoration forestry really look like? Is it different than what people conceive of as forestry? And then kind of tied to that, and sort of the supply chain side of things, I'm wondering if you guys can speak to just proximity of mills. I mean, aside from just tooling and capability of handling smaller diameter logs, any comments on proximity of mills to areas that need to be restored and the economic feasibility of that proximity?
Well, that's what restoration forestry looks like for ponderosa pine. And I think it's pretty well established. Pretty low density, maybe as low as 30 trees per acre across a range of size classes with plenty of openings and lots of understory. And that's actually more regeneration than is really needed to sustain it over time. For Douglas fir, it looks like an old growth stand. If you want that large of trees included in it, or you can cap it off at a 3-foot diameter tree or a 4-foot diameter tree. You don't have to put the largest trees in the 10-foot diameter class. But it's more open, structurally diverse, probably rich in terms of species as well.
What about sort of the extraction? I mean, are we looking at the method of extraction being significantly different?
Yes, it's an entry for Douglas fir could be as frequent as every 15 or 20 years. For ponderosa pine, more like 25 to 35 years. You enter and do these partial harvests and correct the diameter distribution, create the openings, create the regeneration environment. So it's one actually really easy way to think of it is, it's like clear cutting, but on a small scale. I mean, ultimately you have to make growing space available for new trees to get started. You're doing, instead of with even age management where you're pooling all your kids together. That's our current educational model, is even age management. They're all about the same size and they move through time together. And it's pretty large classes are like large clear cuts. The one-room schoolhouse that has all the different ages growing together is much more of the uneven age management or multi-age management approach. But you still have to have room for the little kids to grow. The big kids can't just be killing the little kids all the time. So you have to manage the growing space. And enter the classroom regularly and correct the distribution.
I like the metaphor. That's good.
And
sorry, Marcus, go ahead.
one other thing to add on, since we're talking in a public lands context, some of the restoration activities that we're talking about particularly on the west side of the Cascades, they actually make money. The product that they're bringing out, smaller diameter Doug fir, is a valuable commercial product. And they use those funds to pay for other kinds of restoration, mostly around aquatic restoration. So things like fish passage, upsizing culverts or taking care of roads, the kinds of things that are really designed around habitat, wildlife, which are very expensive. And it's really kind of a beautiful model when you can use the value from the upland thinning and to pay for the habitat improvements and the biological work that happens down below, whether that's salmon or improvements to elk forage. Those kinds of models are used a lot on national forests, and it's used on the Colville as well, or one of their prime projects is paying for fish passage.
Marcus, you mentioned earlier that I think on the Colville National Forest, it was something like $550 to $600 an acre to treat that if there was no market for the fiber. How does, having Vaagen taking the fiber, how does that change the equation?
Well, I didn't get that exactly, but my understanding is that, those things like dramatically reduces the cost or they break even on it. I don't think that these projects are making money, at least not on that forest. But it allows them, they're expanding the scope and scale of the projects that they're taking on. Like the A to Z project is some 50,000 acres. So that's kind of an indicator that they're able to move to larger landscape scale projects because they know that the revenue and the appropriate dollars combined is going to allow them to get multiple treatments done, allow them to get the job done.
Right.
I don't know, Tom, do you have any information on what the treatment costs?
I'm gonna speak real lightly because we are not Vaagen brothers, but I've heard Russ, speak to that question. So hopefully I don't get struck down by lightning here. But I know that that initial A to Z project was definitely not a moneymaker for that whole concept. But it's just like anything. It's kind of that prototype, right? They felt passionately that was the right model to do things in. And so, and again, speaking in very general terms, I know that they have improved that process and see that, but the benefits, however, not always financial, are far greater than that for what that project brought to the table, right? I mean, it was the ray of sunshine on the answer of, man, this is the deal. We're going to move forward and do this. They've got another one down the road down here in Chewelah that will be the next A to Z. And again, I don't know all the details on that, but it opened the light or opened the door, I guess, for this. And they're smart enough and innovative enough. They're going to figure out how to make this work and not only work financially, but for the landscape and for all of that whole big picture. So yes, that's probably as much as I can speak to it, but I know that the initial one was not a money maker, but that really wasn't the point of that. So.
Right. Yeah, and I'll echo that point that I've seen the economic analyses that say you can pay in the near term, you can pay a couple $100 an acre, but it's a net positive return, when these areas are challenged by wildfire and those kinds of things. And that's without putting just the intrinsic value of having a green forest and the wildlife habitat and the fresh water that comes out of it and all that kind of stuff, even when you can't, even when you have a hard time valuing those kinds of things. On the productive west side, the Siuslaw National Forest, they've been doing this kind of thinning and multi-age management in very productive Douglas fir, and every one of theirs makes money and makes a ton of money that they can plow back into road relocation, stream work, all kinds of projects.
Yeah, I guess where my question was coming from is, so Vaagen is located quite close to the Colville National Forest. There's these vast swaths of ponderosa pine in eastern Washington and Oregon. How much of that is, realistically accessible within reasonable distance of a processing facility that could go into mass timber? Because I think we know from Lech's work and others that there's it's technically possible to, technically possible to use ponderosa pine, and the design values are adequate and quite good. But it's that sort of supply chain piece that we don't really, either we don't know yet, or we know it's not going to work. And I'm not sure which that is. But
And transportation distances and cost are
right
deal breakers.
Yeah.
All the logistics of this is going to change as we will see more entrance to mass timber panel industry. And businesses are smart in finding sweet locations, right? So I guess this is going to improve gradually, not immediately, but gradually. When you compare the density, the level of saturation that you have in terms of mass timber panel production in the core area in Europe where this entire technology started in Alpine region, we have ways to go. There is space for companies, for new entrants to the industry that are not going to cut each other's throat. It does not happen in Europe yet, even with this high level of saturation over there. So the logistics of this is going to improve with time. I'm pretty confident.
Well, folks, we might have room for one more question if anybody's got a burning question that they won't be able to sleep tonight if they didn't ask. This is your chance. Well, do you guys have any maybe closing thoughts? Anything you want to share before we call it a night and move on to dinner?
No, I think it was a good discussion. And Tom, definitely appreciated, having your thoughts and your perspective on it. So thank you.
Well, thank you. And I was just going to say the same. I want to be a part of this. I really appreciate it too, to have this group together. And again, back to what I'd said earlier is, doing the right thing for the right reasons. No matter what we say or how we approach this, we're all affected by this in some way, shape, or form. And so hopefully we can all touch it in a positive manner and move the ball in a forward direction and keep this going. And pretty soon, this won't be the how are we going to do this or what is it? It's going to be the normal process, the normal procedure, right? The KPIs will be how do we do this better and better and better, but we have a direction that we're going. And I think it's really exciting for us, for the environment, for the industry, and everybody else that can touch and feel that. So thank you.
So if anything, for closing, I would like to stress again that attacking these issues one by one is definitely going to be more expensive than trying to connect them into a system and finding systemic solutions that will just address all of these issues that we've discussed today revolving around fire, but also other societal and economical problems.
Awesome. Well, thank you all for your time and for your work, being willing to come and share what you're doing and your knowledge with us. I will do kind of a quick plug. Marcus has been working on a project called The Promise of Mass Timber, which is kind of a large educational piece surrounding forestry in the context of mass timber. So Marcus, I don't know when that's exactly coming out, but it's before too long now, right? It's like right on the cusp here.
Yeah, a couple months, probably. Well, we're in May, so next month, June, we're expecting to publish that.
Awesome.
And we'll be pushing it out across all the various channels. Everyone will have a chance to see it.
Yeah, so keep your eyes peeled for that. It's gonna be really interesting. And we're actually collaborating with Marcus on a sort of a fourth piece we're collaborating with everyone here, John, Marcus, Vaagen, TDI, Lech, on a fourth piece, sort of specific to what we talked about today. So we're hoping to put out, to really help kind of shed some light on all of these topics and how they sort of holistically come together in terms of forestry and mass timber. So keep your eyes peeled for that. It's gonna be really exciting. And yeah, thank you guys again. We'll give you a silent round of applause here. Oops, I did a thumbs up. That's supposed to be. All right, there we go.
All right. Go Beeps.
Thank you.
Yeah. Oh boy.
All right. Have a good night, everybody.
Thanks everybody. Have a great night.
All right,
Good to
ya.
see everyone.
All right.
Bye-bye.
Thanks a
Bye.
lot.